trying to maximize or minimize, optimize. First, you draw a picture if possible. Then, you find an equation to optimize. That's the thing that they're asking you to find the minimum or the maximum, the sweet spot. Then, you find the constraint. That's a secondary equation that allows you to do number 3. You solve that and you sub it in to number 1 so that you can get one equation with one unknown because you're in 1D calculus. Then you take the derivative, find the critical values. After that, test the critical values. And then maybe go find your other number. Bam! What are we looking at? We're trying to find two numbers whose difference is 100 and whose product is a minimum. So we're trying to minimize product. So you write the product of these two numbers. I'm using x and y because they could be different. Our constraint is the other thing they tell us, that the difference of the two numbers is 100. So now we're on to step 3. We need to solve for a variable and plug it into 1 so that we can get an equation with one variable. So we do. I'm solving for x here because I figured it was easier, and that's y. So I did. I found that x was 100 plus y. So everywhere I saw an x, I put 100 plus y. And then that was times that y. So then you distribute into that guy, and you get 100y plus y squared. And you take the derivative of that. And just like that, I'm doing step 4. The derivative does turn out to be 100 plus 2y. Yeah, sure. Distribute that y in there and take the derivative. Now I need to find my critical values. But how do I find critical values? I set the derivative equal to 0, and then I solve for y. Y turns out to be minus 50, so I need to test that on a number line, because on more harder examples, you might have more than one critical value. Oh, this was step 5, testing the critical values. My bad. If I test a number to the left of minus 50, like minus a million, my derivative is negative. Then, if I test a number that's to the right of minus 50 like 0, then my derivative is positive. Now here we're going from a negative slope to a positive slope, which makes minus 50 a minimum. So we found the y value. How are we going to go find x? Yeah, we're going to plug it back up into the constraint. So yeah, since x minus y was equal to 100 and y was 50. When we solve for x, we find that that's 50. So what are my two numbers? 50 and minus 50.